Hello everyone, here's Smriti. Welcome to Physics Fact.
Power of a lens. The ability of a lens to bend the light ray which is falling on it. We know that, student, if incident ray falls on a convex lens, it converges, and if incident ray falling on a concave lens, it diverges. So, the ability of the lens to bend the light ray. This ability is known as power of this lens. Okay, so this one is the actual path of the incident ray, and when it falls on a convex lens, bent, and this angle is known as bending angle. Okay, so this bending of light, this phenomena or the ability of this lens is known as power of the lens. Okay, now formula of power of lens, that is P equals to 1 by F. P equals to 1 by F, where F is in meter. Okay, so we also says that power of lens is defined as the reciprocal of focal length. Okay, here the ray are converges, so meet it here focus is produced. And if focus is in centimeter, then you simply written that P equals to 100 divided by focus, and if that is in centimeter. Okay, then what is the unit of this power of lens? That unit is 1 diopter, or we written as 1D. Okay, next we know that from lens maker formula. Okay, lens maker formula, 1 by F equals to mu 2 1 minus 1 by R1 minus 1 by R2. So here that 1 by F, this one is the power of lens. That 1 by F is equals to P. Okay, student? Next, from that bending phenomena, okay, the light bending, when it passes through any lens, that may be convex or may be concave, it bends. If bending is maximum, that means this power is also maximum. How we relate this one? That if this angle is delta, these two lines are parallel to each other. So if this angle is delta, we take as this angle is also delta. So as we take the tan value of this bending angle, as this one is delta, this one is delta, so this one is B, this length is B, this one is P, and this one is H. So what is tan delta? The tan delta equals to P by B. Okay. So what is B? From optical center to focus. This one is the focal length. That means B equals to focal length. And what is P? That P is the height of the object. Because we here take that height of the object. Because we take the lens is very thin and that aperture is very small, so that H equals to 1. Why we take H equals to 1? You got it? Because that lens is very small and we take that aperture of the lens is very small. So we take here H equals to 1. Okay? That H delta equals to, as in case of P, you put the value of H, that is 1 divided by, in case of B, you put the length, that is the focal length. Okay, so tan delta equals to 1 by F. So here we got that tan delta equals to 1 by F equals to P. Okay, so here we got tan delta equals to P. That means what we got? जितना ज़्यादा बेंडिंग होगा उतना ज़्यादा लेंस का पावर होगा. Here bending is very small, so this lens power that is less. But here bending is maximum. Bending ज़्यादा हुआ है, so power is more. But here that power is less. Next, student, here power is maximum or bending angle is maximum, so that focal length is less. यहाँ देखो बेंडिंग ज़्यादा हुआ है तो लाइट रे कन्वर्ज here bending less हुआ है तो light ray meet at this point and that is some distance from the optical center. That means bending जितना ज़्यादा होगा पावर उतना ज़्यादा होगा पर फोकल लेंथ कम होगा. अगर बेंडिंग कम हुआ तो फोकल लेंथ ज़्यादा होगा. So here we got that power is the reciprocal of focal length. This one is the formula. Now we discuss in different case. That means in case of convex lens or in case of concave lens, what is the power? That may be positive, may be negative. Okay.
In case of convex lens, due to that focal length is positive, or we know that power equals to reciprocal of focal length. So as focal length is positive, power is also positive. But in case of concave lens, that focal length sign convention negative, so that power is taken as negative. So here what happens, student? If ray are converges, power is taken as positive. If ray are diverges, power is taken as negative. But go to that mirror case. Here, in case of convex mirror, ray are diverge. That focal length that is positive. Due to ray are diverge, that power is negative. So here that formula P equals to minus of 1 by F. You remember this fact. Okay, student. Next, in case of concave mirror, see the last table. In case of concave mirror, that ray are converges, meet at one point, focal length that is negative, but due to ray are converge, that power is positive. So P equals to minus of 1 by F. Okay.
Now go to combination of lens. Here the first case we consider two convex lens. Both convex lens. So here what happens, student? We take that first lens having focal length f1 and the second lens having focal length f2. So for the first lens, here is the object. So this one is the object distance and this one is the image distance. Okay, and focal length f1. So for first lens, what we got? We know that lens formula 1 by b minus 1 by u equals to 1 by f. So here b equals to b1 and image distance that is u. 1 by u equals to 1 by f1. Then for the second lens, for first lens, this one is the refracted ray. But for the second lens, this refracted ray is the incident ray. Yes, this one is the refracted ray for the first lens. But this refracted ray is the incident ray for this second lens. So what is the object distance? This B1 is the object distance. Okay. So further in second lens, deviation occur. The ray deviates its path. So for the second lens, image is produced here. Instead of I1, image is produced at I. So this one is the final image distance. Okay, student. So for the second lens, what happened? That 1 by V minus 1 by V1 equals to the focal length F2, 1 by F2. Okay. So take as equation 1 and equation 2. Adding equation 1 and 2. Okay. Here 1 by V1, 1 by V1 cancel. We got 1 by V minus 1 by U, that is equals to 1 by F1 plus 1 by F2. So here that 1 by F1 plus 1 by F2 is the combination of focal length, take as 1 by F. So here we got that this one is the object distance and this one is the image distance and the two lengths take as focal length F1, F2 and its combination, this focal length is taken as F. So what you got from these two equations? That the combination of two convex lengths. The combination of two convex lengths. So what is the total focal length? That 1 by F equals to 1 by F1 plus 1 by F2. Okay, student? As we know that 1 by F, that is the power. Power is the reciprocal of focal length. So the total power is equals to 1 by F1, the power of first lens, and 1 by F2, the power of second lens. So the total power P is equals to P1 plus P2. Okay. Here we take one lens is convex and another lens is concave having focal length f1 and f2. We know that, student, for convex lens that focal length is always positive, and for concave lens the focal length is always taken as negative. Yes. So what is the combination of this lens? That 1 by f equals to, for convex lens that is 1 by f1 plus, for concave lens we know that the focal length sign convention negative, so minus f2. Okay. So as we written that 1 by f equals to 1 by f1 minus 1 by f2. Now student, here we take three condition. Okay. If f is a positive value, f is a positive value, that means here we put the focal length of f1 and f2 for both convex and concave lens and solve the equation. If that f is a positive value, this one, f is a positive value, then the combination of convex and concave lens behave as convex lens. एक convex lens ले है और एक concave lens ले है. ओके, जब हम इसका फोकल लेंथ पुट करेंगे और सॉल्व करेंगे, अगर f पॉजिटिव आया तो इन दोनों का कॉम्बिनेशन कन्वेक्स लेंस के तरह काम करेगा. समझ आया? और इफ f इज नेगेटिव, ओके, दैट मींस इन दोनों का कॉम्बिनेशन कॉन्केव लेंस के तरह काम करेगा. दैट मींस कॉन्केव लेंस में क्या होता है, रे डाइवर्ज हो जाता है, एक पॉइंट से आने का जैसा दिखता है, वैसे ही इन दोनों का कॉम्बिनेशन बिहेव करेगा. ओके, देन इफ f is infinity, that means that 1 by f equals to 0. f is infinity, that means 1 by f equals to 0. Okay, in this case the combination of convex lens and concave lens as a plain glass plate. Okay student, you remember this one. The basis of this power of lens and combination of lens, we discuss some numericals. An optician prescribed spectacles to a patient with a combination of convex lens of focal length 50 cm and concave lens of focal length 25 cm. What is the combination of this spectacles and what is the power of the spectacles? For student, here that convex lens have focal length 40 cm. Okay, then concave lens have focal length 25 cm. You individually calculate the power of each lens P1, P2 and combine that power. Okay, P1, P2, you can calculate the total power. Okay, this is one method. Another method, you take that 1 by f equals to 1 by f1 plus 1 by f2 and simplify this one. Then as you got 1 by f, that 1 by f equals to p, the total combination of focal length, that is equals to the total power. Okay, the two method. Okay, for convex lens. Okay, so what is power p1? That is 1 by f1. That is because of here that value is in centimeter, so that is 100 by 40 centimeter. That is equals to p1 equals to 2.5 diameter. Okay, next for concave lens, that is P2 equals to 1 by F2 and that is equals to, that is given in centimeter, so 100 by 25, that is equals to 4 diameter. Then what is the total power? The total power P equals to P1 plus P2. As because of the second one is the concave lens, the power is in negative sign. Okay, so then this one equals to minus 1.5 diameter. Okay student, so that power equals to minus 1.5 diameter. Next, go to the second example. The two lenses of power 6 diameter minus 2 diameter are placed in contact. That means one is a convex lens and another one concave lens. Find the power and focal length of the combination. So first P1 equals to 6 diameter and P2 equals to minus 2 diameter. So what is the total power? That is 6D minus plus of minus 2D. Okay, that means 6D minus 2D. So what is power? P equals to 4D. So what is the focal length of the combination? The focal length 1 by f equals to P. Yes, P equals to 1 by f. Power is the reciprocal of focal length. So what is f? F equals to 1 by p. Okay. So here put the value 1 by 4 diameter. Okay, 1 by 4t. So 1 by 4, that is equals to 0.25 meter. So in your given question, because of your 0.25 meter is not given, but 25 centimeter is already given in your example. So that your answer is F equals to 25 centimeter. Okay students?